It contains ice. And also some water. I'm giving diagram in books, nothing will be there, only question will be there. So a student must have some imagination. That's why I'm just trying to help you with the diagram. Huh? Okay, this will be 200 gram of water, 100 gram of ice. Temperature is 0 degrees Celsius. 200 gram of steam will enter it. Water equivalent of calorimeter. So you can write 20 gram is the water equivalent of calorimeter. What will be the final content and temperature of the calorimeter? So 200 grams of steam at 100 degrees Celsius will enter. So 200 gram of water and 100 gram of ice at 0 degrees is there in calorimeter. What will be the final temperature and content of calorimeter? The same ideas. Here water equivalent of calorimeter also will bring it. 200 gram of steam at 100 degrees Celsius enters a calorimeter that contains 200 gram of water and 100 gram of ice at 0 degrees Celsius. Find final temperature and content of the calorimeter. Water equivalent of calorimeter is 20 gram. Okay, let's get into the calculation part. What can be final temperature? And it can be 100, it can be less than 100, but it cannot be more than 100. Am I right? If you say more than 100, there's a big problem. Finish short and nobody can help you. I'll have water, huh? Okay, just work out. There's a you can't just say that any situation you can bring. A student must be in a better position to understand the methodology here. There's no fun in practicing several numericals on this. The methodology, if you understand, I think you can do it. So first, heat required for all ice to melt. Q1 equal to M1 LF. So symbols, 100 gram of ice, 200 gram of water. What is M3? 200 gram of steam. Okay, these are for our reference. We are taking all these symbols. Now this should be equal to 100 into 80, 800 calories, the same thing. The temperature
Sir,
of the
8,000, sir.
8,000. No, the whole temperature of calorimeter, let it become 100. Sir, how do you can say? I don't know. I'm just making a guess. Okay, let the old steam condense. Let's see what will happen. See, this cross check I'm going to do here. No, no. Sir, like, is it a luck? Not luck. See, either you should assume one situation. Let the final temperature of calorimeter be 100, calculate the heat required. Is that much of heat, is it provided by the condensation of steam? That's what we have to do, no? Is it old steam condenses or not? So now heat required to rise the temperature of calorimeter from 0 to 100 degrees Celsius. Let's see that one. What all this heat? It should be water equivalent of calorimeter, then m1 gram of I newly formed water, then m2 gram, 200 gram of water, which is already available. So water equivalent 20 into 100, m1 100 into 100, 200 into 100, 32,000. Okay, this much of total, that one. Who should provide this? By the condensation of heat. So we'll get into the next part. Heat available if the old steam condenses. There's a I don't know. I'm just checking myself. Heat available when old steam condenses. I'll call that as, say, some Q dash. This should be M3 into LV. So this should be equal to 200 into 540. So 10800. 1,08,000 calories is available. But what we needed, 40,000 calories is needed. No, look at this. So what is Q dash? Is it greater than Q1 plus Q2 or less than Q1 plus Q2? 1,08,000 is less than 40,000. No, so therefore, is it all steam should condense? No, only a part of steam has to be condensed here. So what is the Q dash? In fact, greater than Q1 plus Q2. So therefore, the whole steam, a part of steam only will condense. So final temperature, what do you expect? 100 or less than 100? Should be 100 only. So therefore, now what I do is like Q1 plus Q2 equal to M dash into LV. What is M dash? Mass of steam that condenses. So this will be 8,000, 32,000 M dash into 540. Anybody value?
74.
74. Huh? Yeah. So 74 grams of steam condenses. No. What shall we do this 74 grams of steam condenses? So remaining, how much of steam will go out? 166 grams of steam will come out here.
126.
126 grams of steam at 100 degrees will come out. So what will be the final content of calorimeter? 374 grams of water at 100 degrees Celsius. Will I agree? This one? I think total. This is what we did. You should not add 20 gram of calorimeter. Final content means content. How much content here? Not the total mass of system. These are very popular problems. A student has to put effort. So you can draw block diagram also. Here also it will be similar thing. I set 0 degrees Celsius. So it will melt. It will become 100 gram of water at 0 degrees Celsius. And you have to add 200 gram of water at 0. Together what will happen? If they get added up, will become how much? 300 grams of water at 0 degrees Celsius. Here I'll be supplying Q1 heat. Next, this 300 gram of water should become how much it is? 100 degrees Celsius. So for that Q2 amount of heat, even water equivalent of calorimeter should be there. I need not to show that. WC, you write it. It will be understood. So who should provide this Q1 plus Q2? The steam. $200 gram of steam at 100 degrees Celsius. So it will become how much will be? 126 gram. So 126 gram. So some steam will condense, no? So that will be heat released. So don't call Q dash, M dash into LV, and that heat what is released will be given for Q1, Q2. So if you want, you can write it as Q3. So what is Q3? We don't know that one, no? So therefore I'm writing Q3. So this Q3 only what happened will be taken as Q1, Q2. Those who are finding very difficult, at least through this block diagram, try to understand. Can it happen that directly, can I mix steam and ice? Yes, we can do that also. We'll take next problem. We have ice here. Minus 10 degrees Celsius. 10 gram of ice at minus 10 degrees Celsius and 20 gram will take 20 gram of ice at minus 10 degrees and 10 grams of steam at 100 degrees Celsius. I'll send it. What will be the final temperature of the calorimeter? Final content and temperature of calorimeter. Water equivalent of calorimeter negligible. There's the initial. So 10 gram of steam at 100 degrees Celsius passed into calorimeter that contains 20 gram of water at 20 gram of ice, no? Find the final temperature of calorimeter. Okay, now I can mix steam with ice. First, what do you expect temperature? Let it rise for the whole ice to melt. First, temperature of ice to increase from -10 to 0. Heat required to increase from 0 to -10 to 0 degrees Celsius. Q1, so this should be mass of ice, specific heat of ice, 0 minus of -10. Mass of ice 20, specific heat of ice, this is 1 by 2, 10. 100 calories. Okay, this one. Okay, now again, for all ice to melt, heat required for all ice to melt. Q2 equal to into m ice, mass of ice into latent heat of fusion. Mass of ice is how much? 20. This is 8. 1600 calories. So total how much it is? 1700 calories is what needed here. Okay, for steam condensers, old steam condensers, let's see what will happen. With the old steam condensers. 5400 calories is available, no? If the old steam condensers, 10 into 540, 5400 is available. So how much we needed? Just 1700. So what do you expect temperature of calorimeter? Should increase to 100. So now for it to become 100 degrees Celsius, so 20 into specific heat into 100. So how much is needed? 2000. 20 into 100, 2000. So 2000 plus 1700. 3700 calories, or so like 3700 calories is what needed to rise the temperature from 0 to 100. If old steam condenses, 5400. So what do we expect? Old steam should condense or only a part of steam to condense? So I'll get into this one. Heat required to rise the temperature of 20 gram of water from 0 degrees Celsius to 100 degrees Celsius. Mass of water 20 into 1 into 100. From where this Q1 plus Q2 plus Q3 should come, the steam. If the old steam condenses, how much we know? 5400. Is it old steam should condense? No, only a part of steam. So I'll do one thing. M dash, I'll write part of stream, mass of stream condenses. Q1 plus Q2 plus Q3 equal to M dash into LV. So this will be 100, 600, 2000, M dash we don't know, and this is 540. Anybody value? 6.85. This much of steam will condense here. So remaining how much will leave? 2.25 or is it 3.25?
15, sir.
3.15. 3.15 gram of steam, what will happen? Will leave the calorimeter. So what will be the final, at least if you can able to understand, it's good, like because you check the advanced, no, we have questions based on this. What I'm discussing, no, similar to this one. .85 grams of, sorry, 3.15. Steam at 100 degrees Celsius will leave. Finally, what we'll get? We'll get water. We don't get ice. Ice will not be there, you know. .100 degrees Celsius water. Now, what will be the final content? 20 plus 26.85 grams of water. So don't think that only steam and water, even the steam and as well as ice will have interaction. And this is what the condition arises. I can mix steam and ice. I can mix the water and this one. So these are the different types of numericals what happen you may encounter. Okay, let's take one more problem on this. There's a final. Let me write it. There's an initial.